shouldn't have left you without a strong rhyme to step to. Think of how many weeks shows you slept through.
All right, guys. Well, that song came to mind, this old school rap, Eric B. and Rakim, because it's been a long time since we did fractions. And we should not have left them because guess what? They are a part of our lives and we need to be proficient in them for cooking, for just doing so many things. I guess some of you say, I ain't cooking. But anyway, so fractions are just important and everyone in the entire world expects you to know them. Let's get started. 1/3, what we're doing today is we're solving algebraic equations with rational coefficients. Rational. What word do we hear when we say rational? Ratio is a what? A number separated by a colon, but it can also be a fraction or a decimal. So we're going to be dealing with algebra with fraction coefficients as well as decimals. Okay, guys? Okay, so I'm rushing and I apologize because we have 15 minutes to get through this video. All right, so 1/3 of a number is 15. So 1/3 of some number. Now we're going to use our bar to help us determine what that number is. So the bar is the number that we don't know what it is. So we're going to draw ourselves a bar and we're going to identify it as X. And then we're going to break it into thirds. And when we break a bar into pieces based on the denominator, we know we draw one less number of lines. So here the denominator is 3, so we actually are drawing 2 lines. Okay, so now we have each of these sections is 1/3 of X. 1/3 of X. My writing is a little sloppy. 1/3 of X and 1/3 of X. Okay. But how much are we actually talking about? 1/3 is 15. So just one of these is 15. We want to know what the entire X is. And I bet you can tell me what that is. If 1/3 is 15, the next third is 15, and the next third is 15. So what would you say the value of X is? 30. 15 times 2, or 15 plus 15 is 30. And 30 plus 15 is what? I can hear some of you saying 45, and that is terrific. Let's write out an equation and create an algorithm for this. And I think we've done this once or twice. Okay, but this is a review. So 1/3 of X, we don't know, it's variable, we don't know what the number is, equals 15. And in math we can write an equal sign for. So 1/3 of X means 1/3 times X. So let's put 1/3. Because of in math means multiply. 1/3 of X is 15. Now, since we already determined that our entire X is 45, what do we do with the 3 and the 15 to get to 45? Add? No, because 3 plus 15 is 18. Subtract? No, you know that's not the case. We multiply. So, 3 times 15 is 45. Well, what did we do to the 1/3? We flipped it. That should bring to mind the algorithm for dividing fractions. Well, what does that have to do with this equation? Well, this is a multiplying fraction equation. And to undo multiplication in algebra, we divide. So to divide fractions, we multiply by the reciprocal what? Right, we learned that. So 3 divided by 3 is 1. 3 divided by 3 is 1. We're reducing by the greatest common factor of 3. And X is 15 times 3. 15 is a big gun. We'll put them over 1. 15 times 3 is 45. We don't need to put 45 over 1 because it's a whole number and we know that. Okay, let's ease on down the road. Ooh, that's kind of sloppy. I've done this a few times. Okay. All right, so now let's look at the next one. And this little snail is saying that 2/5 of a number is 16. Okay, find the number. Okay, so again, well, why don't we first write out our equation. 2/5 of X is 16. Are you comfortable with writing an equal sign for is? Okay, because we're translating words to math. That's called algebraic translations. Okay, so now we're going to write 2/5 X because of is multiply. Now we're multiplying The variable is right next to the fraction, equals 16. Okay, there's our one-step equation. Okay, so now we have our handy-dandy bar diagram, and we should move him or her over. Oh, it's a little weird here. I'm going to switch our order here. Sorry. Send forward, send to the back. Okay. Oh, I didn't mean to do that. But anyway, the work's done for us, so I'm going to go with it. I'm going to go with that, Terry. Why not? Okay, so here we have 2/5 of a number is 16. So we have this bar being x. We partition it by drawing 4 lines, 1, 2, 3, 4. You do that on your paper because your paper is blank. And then we're going to write in each section 1/5 of x. 1/5 x, because there's 2/5. And then we're going to identify that the 2/5 has a value of 16. Okay. And I'm guessing that you probably know that if 2/5 is 16, each of these has a value of 8. And why is that? Because 16 divided by 2 is 8. And I'm going to go ahead and take the liberty of filling out the rest of the 1/3 sections. Okay. So now we already know that x is going to be equal to 8 times 1, 2, 3, 4, 5, which is going to be 40. So we can put 40. But now let's do the algorithm. And Miss Littles wants you to do it this way. So I'm going to cover this back up. And I am thankful for the snail's input. But here's how we are going to do it. So 2/5 of x equals to 16, and that's multiplying fractions. So we need to divide to get x by itself. So to undo this, we're going to multiply by the reciprocal. And reduce here by the greatest common factor. We're left with x is equal to, put 16 over 1. 2 divided by 2 is 1. 16 divided by 2 is 8. 8 times 5 is 40. Ta-da! Good job, right? Not bad, not bad. We're going to make this a little bit trickier. So now what we're going to do is I'm going to we'll do this one. Let's skip down because I'm going to have you do the first two on your own. Okay, no, I'll do it with you. I'll be generous. Okay, let's write down 2/3 of x equals 4. So we have a bar here and we have it in thirds. So let's write in each one 1/3 of x. Okay, so we're only dealing with 2/3, and the 2/3 has a value of what? 4. So I'm guessing that you know that if 2 of the thirds is 4, each third has a value of 2. 4 divided by 2 is 2. And then our x has a value of 6, right? Okay. So that's great, but of course we're not going to draw bars each time we do fractions. So we will learn our algorithm, which is our process, which isn't difficult at all. So let's write 2/3 x is 4, and some of you are already doing this, and that's fantastic. This is multiplying fractions. To undo it, we need to divide fractions, which is multiplying by the reciprocal, which is flipping it. All right. Cross these out, reducing by the greatest common factor diagonally. And then let's put 4 over 1. And instead of multiplying 4 times 3, let's reduce 4 diagonally by 2. So x is equal to 6. And we had gotten that already. So let's move down. All right, and check it. And when we check our math, what do? We rewrite the original equation. So let's write 2/3 x equals 4. Let's plug in our value for x, which is 6. 2/3 times 6 over 1 equals 4. And what do we do with our 3 and our 6 here? They can be reduced by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And 2 times 2 is 4. And guess what? That checks out. All right, let's move on down the road to this next problem. Pardon me. All right, and I already have bars on mine just to expedite the process. So let's write out first what this is saying to us. It's saying to us that 3/5 of x plus 2 is 17. Plus 2 is 17. So here we have our x, and then we're dealing with 2/5. 1/5 of x, 1/5 of x. But we have an extra value here. Our x currently is, or 2/5 of x is currently increased by 2. So, I thought that was going to give me something different. 2. Oh, I don't like that. Undo you. Okay, so let's get the highlighter and let's just highlight. A little bit of a highlight, and we increased our x by 2. Okay, and all of that currently totals 17. And the goal in algebra is to determine what the variable is, x. So what's in the way of that? This blue space is in the way of it in the first place. So let's get rid of it. Can we just cross it out? No. We have to reduce it. And if we reduce 2 on one side, algebra is a scale. So if we reduce it by 2 over here, that means the other side will become too heavy. So I have to reduce the other side by 2 as well. We don't want the 2 here because we are trying to figure out what x is. The 2 is in the way, so we need to get rid of it. We can only get rid of something by doing the opposite or creating a zero pair. Okay, so 17 minus 2 is 15. We have no more extra 2, so our x is currently, we don't know what x is, but 2/5 of x is now 15 because we got rid of the 2. All right. Or I'm sorry, 3/5. Woo-wee. And I know some of you caught that because we always help each other. Okay? So 15 divided by 3 is what? 5. This is a little sloppy, but I'm hoping you are pressing pause and paying attention. And pressing pause, and filling it out on your own. So now we have 5 5s, and that means our x has a total of 25. So now, this is for understanding, but obviously, it's probably going to be just as handy if we do the algorithm. So let's write down 3/5. Well, you are not nice looking, you 3. All right, so 3/5 of x plus 2. A little bit too heavy because our 2 is there. So we want to know what x is. So the first thing we need to do is get rid of the 2. The 2 is in the way. So we want to reduce by 2 because the 2 is extra. It's extra. You're extra. Okay. So now we have 3/5 of x is 15. And we know when we multiply fractions to undo multiplication, we do what? We divide. And the algorithm for dividing fractions is multiplying by the what? Reciprocal, which means to flip the fraction. Okay, let's do that on both sides. 5/3. Reduce over here. I hope you've gotten that. And then look what we have here. 15/1. And then we have a 3 that can divide into the 15 to reduce it. And 5 times 5 is 25. So let's move that down. And I'm hoping, and not hoping, but I'm thinking on your paper you have more room. X is 5 times 5. So x is 25. And I think when we do this in class, I'm going to have you do it on a sheet of paper. Okay, so now let's check it. Is this correct? 3/5 x plus 2 is 17. So let's write out our original equation. 3/5 x plus 2 is 17. And guess what? We know what x is now, or we think we know. So let's plug it in. 3/5